Welcome to the DIY Honda Garage channel. The DTC P2563 indicates an issue with the turbocharger's wastegate control actuator position sensor for the Honda Civic 2022 and later models. This sensor monitors the position of the wastegate, which regulates the amount of exhaust gas that enters the turbocharger. If the output voltage from this sensor falls outside predetermined limits, the Engine Control Module, ECM, detects a malfunction and stores this diagnostic trouble code. This is crucial for engine performance and efficiency, as the wastegate controls the turbo's boost pressure. The sensor is integral to the turbocharger assembly, closely linked to other components such as the Powertrain Control Module, PCM. When diagnosing this issue, technicians will follow specific steps to isolate faults in the sensor, turbocharger, or the associated circuitry. The turbocharger wastegate control actuator position sensor plays a vital role in optimizing engine performance by regulating boost pressure. This component is integrated with the turbocharger itself, which is typically located near the engine's exhaust manifold. The sensor's primary function is to provide feedback to the PCM regarding the position of the wastegate. If the control signal deviates from designated parameters, the PCM interprets this as a malfunction, potentially leading to inefficiencies or engine damage. Understanding the role and location of this sensor is essential for effective troubleshooting. Being aware of its relationship with other engine components can help technicians quickly diagnose the root of the issue. Various factors can lead to the triggering of DTC P2563. One of the primary causes may be a faulty turbocharger, which could affect the wastegate's function and thereby the position sensor's output voltage. Another potential cause is the failure of the wastegate control actuator position sensor itself. If it is defective, it might report incorrect values to the PCM. Additionally, electrical circuit issues, including open or shorted wires in the connections, especially regarding circuits such as VCC2, DCWGL, and SG2, can contribute to generating this diagnostic code. Each of these possible causes will require specific testing to confirm or rule out as the source of the problem. When DTC P2563 is present, several symptoms may manifest, primarily affecting vehicle performance. One noticeable symptom is reduced engine performance, particularly during acceleration, as an improperly functioning turbocharger fails to provide adequate boost pressure. Drivers may also observe the engine warning light illuminated on the dashboard, signaling a need for diagnostic attention. Furthermore, there may be inconsistent turbo boost, resulting in irregular engine behavior during various driving conditions. Each of these symptoms can have a significant impact on vehicle handling and must be addressed promptly to ensure optimal performance and safety. The first troubleshooting step requires the technician to turn the vehicle to the on mode. This allows for proper diagnostic communication and sensor readings. Following this, the Honda Diagnostics System, HDS, should be utilized to check the voltage output from the wastegate control actuator position sensor. If the voltage reads less than 0.31 volts or exceeds 4.78 volts, this confirms a failure condition that is consistent with the DTC P2563 code. It is critical to accurately interpret these voltage ranges, as they provide essential insights into whether the wastegate control system is functioning within normal parameters or if immediate intervention is necessary. For the second step, ensure the turbocharger 5P connector is disconnected. This disconnection from the turbocharger allows for isolated testing of the output voltage to see if it confirms normal operating conditions. With the ignition in the on position, the technician should measure the output voltage, which should ideally register around 5.0 volts. If the voltage aligns with this expected reading, It suggests that the turbocharger is functioning as it should and that the potential issue lies elsewhere. Conversely, if the voltage is not in this range, it could indicate a fault in the turbocharger itself, necessitating further inspections or component replacements. In this third step of troubleshooting, start by jumping the turbocharger 5P connector terminals number 3 and number 4. This action creates a temporary circuit that simulates normal conditions, allowing for more accurate testing. With the vehicle again in the on mode, confirm the HDS readings for the wastegate control actuator position sensor. The expected value should be less than 4.78 volts. If this condition is met, it would indicate that the turbocharger is most likely functioning as intended, and the issue may stem from other related components or circuitry. Should the reading fall outside this expected value, further investigation is warranted to ascertain the specific failure point. The fourth step focuses on inspecting the electrical circuits associated with the turbocharger and its sensors. Before disconnecting the PCM connector, ensure that the SCS line is jumped with the HDS, maintaining this state for at least 1 minute. Proceed to examine key circuits, including VCC2, DCWGL, and SG2 for any open or shorted wires. Each of these circuits plays a critical role in providing power and signals to the turbocharger's actuator. Normal testing results should show less than 1 ohm resistance, indicating no breaks in continuity. If any of these readings show greater resistance or a short to ground, it clearly indicates a circuit-related failure that must be resolved to rectify the DTC P2563. The final troubleshooting step involves the inspection of the powertrain control module, PCM, if all other components tested show normal functioning. This step is crucial because if the turbocharger, its sensor, and associated electrical circuits have been verified as operational, the PCM could be the source of the problem. The PCM, responsible for managing engine functions and performance, can occasionally fail, leading to erroneous readings and control issues. Identifying any abnormalities in the PCM will indicate that it should be replaced to resolve the trigger for DTC P2563. Ultimately, a careful analysis here will ensure that all viable options have been exhausted before concluding that the PCM is indeed the culprit. Once all necessary repairs have been completed, it is vital to perform a final verification of the work conducted. This process begins with using the HDS to confirm that the repairs have effectively resolved the issue associated with DTC P2563. After verification, the next step is to clear the diagnostic trouble code from the system, allowing for a fresh start. Following this, it's crucial to retest the system under driving conditions to ensure that the fault does not reappear. Continuous monitoring for any new codes or issues must take place to confirm that all repairs made successfully addressed the initial problems without introducing new ones. This step ensures the vehicle is back to optimal operating condition. Preventive maintenance plays an essential role in mitigating issues like DTC P2563 from arising in the first place. Scheduling regular inspection intervals for the turbocharger and related components is vital to identify any wear or potential malfunction before they escalate into significant problems. Technicians should monitor turbocharger performance actively, listening for unusual noises, and observing changes in acceleration or efficiency can help in early detection of faults. Additionally, it is important to routinely check the electrical connections associated with the turbo system. Ensuring that these connections are secure and free from corrosion can prevent circuit-related failures, contributing to the overall longevity and reliability of the vehicle. In summary, DTC P2563 denotes a malfunction within the Turbocharger Wastegate Control Actuator Position Sensor System, indicating a need for thorough diagnostics to determine the underlying cause. Understanding the mechanics of the sensor and the associated circuits is critical for identifying the failure. Each step in the troubleshooting process is aimed at isolating potential faults, whether they originate from the turbocharger itself, its sensors, or associated wiring. By adhering to the defined troubleshooting steps, technicians can effectively diagnose and resolve the issue. Lastly, implementing regular preventive maintenance will greatly aid in avoiding the recurrence of such issues, ensuring reliable vehicle operation across Honda Civics 2022 and beyond. Please like and subscribe to the channel. See you next time.